Okay, this is problem, this section is numbers 20 through 30. This is problems 24. This is problem 24. A principal is informed that among 1,250 students in our high school, the GPA is 2.13 with a standard deviation of 0.61. What's the margin of error? Well, they took all the students, all 1,250, and they took an average. Because they took an average of because they took a census, there's no margin of error. This is the variation in GPAs, but there is no margin of error because they took a census. So consequently, this is 0. If you take a census, we know the true population parameter. So the true average is 2.13. The true population standard deviation is 0.61. So this is actually 0.61. This is not a sample average. This is 2.13. It's the real deal. Okay, that is the population parameter. All right, suppose 48, this is number 26. Suppose 48, suppose the interval 48 to 65 is a 95% confidence interval estimate for a population mean. Which of the following is true? There is a 0.95 probability. We don't use probability when we talk about confidence intervals. Can't be right. If 100 random samples of the given size are picked and a 95% confidence interval is calculated from each, the mean will be in 95% of the resulting intervals. That's not bad. That's possible. We'll come back to it in a moment. Possible. If 95% intervals are calculated from all possible samples, mu will be in 95% of these. This is true. This is the best answer. And you're like, wait a second, B and C are really close, and they are. So what this says, in repeated sampling, we expect to capture 95% of the time. In other words, it works 95% of the time. So if we take all possible samples, 95% of them will capture it. If 100 random samples are picked, we expect that 95% will be. Now there's going to be some variation. It might be 94, it might be 96. It works 95% of the time, but we're going to get closer and closer to that true 95% value as we get closer to infinity or as we get to the all possible. So while this is not a bad answer, this is a better answer because this was all possible ones. Okay, that is one that I would expect. All right, number 30. A quality inspector plans to test a sample of 40 bottles of soft drink labeled as 20 ounces. If she finds the mean content is to be less than 0.98, she will have the bottling machinery stopped and recalibrated. If it is known the machine operates with a standard deviation of 0.75. So this is really key. They're telling this is a population standard deviation, so we're working with a Z here. What is the probability that an inspector will mistakenly stop a machine that is delivering a mean of at least 20 ounces? So first off, my null hypothesis is the mean is 20. The alternative is that it's less than 20. When are they going to stop doing this? Well, let's draw a picture of it. Picture says this is the mean. This is 19.8. So if X bar is this way, then I'm going to reject. So we want the probability that X bar is less than 19.8. This is the probability that Z is less than 19.8 minus 20, standard deviation 0.75, and we had a 40 bottle sample. So I can go ahead and do a Z test for this. Stat test, Z test, mean of 20, standard deviation 0.75, X bar 19.8, sample size 40, less than, calculate, and I end up getting 0.0458. So this is my closest response. And you're like, well, how did I know that it was a p-value? A p-value is the probability of getting a test statistic as extreme as 19.8, given that this is true. So given that it was actually producing at 20 ounces, there's a less than 5% chance that I would get a value of 19.8 or smaller. So that's why we're looking for the p-value.